Hello everyone. Today we're going to discuss about variation. Now if you want to understand the word variation, you should know the two important terms related in this topic. The first one is the word constant and the second one is a variable. So it is important to know how they differ from one another. When the value of a quantity does not change under different conditions, then it is called a constant. On the contrary, when the value of a quantity changes under varying conditions, then it is what we call a variable. Take a look on the picture. If we're going to relate the picture on the term is stated above, the word constant and the word variable, which of the picture is stand for a constant and which of the picture is stand for a variable? May I have your answer? Yes, you're correct. The price of the rice per kilogram is stand for a constant, or it is the constant, and the number of kilogram stand for the variable. So meaning that the total price of a rice depends on the number of kilograms. And this is an example of direct variation. Why direct? Because there is a direct relation between the total price of the rice and the number of kilogram. Meaning, if there is an increase in the number of kilogram, there is also an increase in the total price. Or, if there is a decrease in a total price, then there is also a decrease in the number of kilograms. Before we proceed to the topic, let us solve some of the equations related to ratio and proportion. Equation number 1. 2.4 over x equals 2 over 9. So the objective is to determine what is the value of x. And by applying the cross multiplication, we're going to multiply 2 by x. So it becomes now 2x. And 2.4 times 9, of course, the product is 21.6. So this time, we're going to divide both by 2 and the value of x is 10.8. Now, how about example number 2 or equation number 2? 1.6x equals 1.8 times the quantity of 24.8. Of course, we're going to simplify now the right member of the equation. So we're going to copy the left member. So it becomes 1.6x equals 44.64. And then, of course, you're going to divide both by 1.6. So the value of x is 27.9. After we solve equation 1 and equation number 2, so this time we are going to determine which table represents linear function. Let us check table number 1. What do you think? Is it a linear function or not? And of course, the answer is not. Why? Because the first difference in y are not equal. How about table number 2? Is it a linear function or not? The answer is yes. Why? Because the first difference in y are equal. Let us proceed to the topic, the special type of linear function or what we called a direct variation. What is a direct variation? Direct variation is a relationship between two variables, x and y, that can be written in the form of y equals kx, where k is not equal to 0. In this relationship, k is the constant of variation, and for the equation y equals kx, y varies directly as x. Or, we can also read the equation y equals kx as y is directly proportional to x. A direct variation is a linear equation in the form of y equals mx plus b, where b equal to 0, and the constant of variation k is the slope. Because b equal to 0, the graph of a direct variation always passes through the origin. Let us now proceed to example number 1, writing and graphing direct variation. Given y varies directly as x and y equals 27 when x equals 6, write and graph the direct variation function. First, we're going to translate the given statement into equation. Y equals kx, or we can read it as y varies directly as x, or y is directly proportional to x. Now, since the value of y equals 27 and the value of x is 6, we're going to substitute it 27 for y and 6 for x in the equation. So it becomes now 27 equals k times the quantity of 6. Solve for the constant of variation k. So the value of k now become 4.5. Then write the variation function by using the value of k, which is 4.5. So the equation of the variation is y equals 4.5x. Let us now graph the direct variation function. The y-intercept is 0 and the slope is 4.5. Why? Because the equation of the variation is y equals 4.5x. Now you may observe that the graph of the equation passes through the origin. Now let us now check the value. Substitute the original values of x and y into the equation y equals 4.5x, and you may observe that 27 equals 4.5 times 6 are both 27. Based from the first example, so therefore we can conclude that if the graph passes through the origin and form a straight line, then the equation is direct variation. Let us now proceed to example number 2. Given y varies directly as x and y equals 6.5 when x equals 13, write and graph the direct variation function. Let us translate the statement y varies directly as x into equation, and the equation become y equals kx. Now, since the value of y equals 6.5 and the value of x equals 13, we're going to substitute 6.5 for y and 13 for x. So it becomes 6.5 equals k times the quantity of 13. Solve for the constant of variation k, and the value of k becomes 0.5. Write the variation function by using the value of k, and the equation of the variation is y equals 0.5x. Graph the direct variation function. The y-intercept is 0 and the slope is 0.5, since the equation of the variation is y equals 0.5x. And then check the value. Substitute the original values of x and y in the equation. Y equals 0.5x. So it becomes 6.5 equals 0.5 times 13. Now you may observe both are equal to 6.5 and the graph form a straight line. If you want to find specific values in a direct variation problem, you can solve for k and then use substitution, or you can use the proportion derived below. Y sub 1 equals kx sub 1, or it is the same as y sub 1 over x sub 1 equals k. And y sub 2 equals kx sub 2 is also the same as y sub 2 over x sub 2 equals k. If k sub 1 equals k sub 2, so therefore, y sub 1 over x sub 1 is also the same as y sub 2 over x sub 2. So let us now solve direct variation problems. Problem number 1. The cost of an item in pesos, P, varies directly as the cost of the item in dollars, D, and P equals 3.85 pesos when D equals $5. Find D when P equals 10 pesos. Method number 1. Let us find the value of K. Translate the statement P varies directly as the cost of the item in dollars, D. So the equation is P equals KD. Since the value of P equals 3.85 and the value of D is $5, so let us substitute. And the equation becomes 3.85 equals K times the quantity of $5. Solve for K, and the value of K is 0.77. Write the variation function. Let us now use 0.77 for the value of K and replace it to the equation so that we can find the equation of the variation. And the equation equals 0.77D. Substitute 10 for P and the equation becomes 10 equals 0.77D and solve for D, and the value of D is 12.99. Method number 2. Use a proportion. Since K sub 1 equals K sub 2, so therefore, P sub 1 over D sub 1 equals P sub 2 over D sub 2. Substitute the value, so it becomes now 3.85 for the value of P sub 1 over pi for the value of B sub 1 equals 10 for the value of B sub 2 over D. Find the cross product. Multiply 3.85 times D, so it becomes 3.85D, and 5 times 10, of course, the answer is 50. Solve for D, and the value of D is 12.99. Example number 2. The perimeter P of a regular dodecagon varies directly as the side length S, and P equals 18 inches when S equals 1.5 inches. Find S when P equals 75 inches. Method number 1. Find the value of K. Let us translate the statement P of a regular dodecagon varies directly as the side length S. So the equation is P equals KS. Since the value of P equals 18 and the first value of S is 1.5, let us substitute it to the equation. So the equation becomes 18 equals K times the quantity of 1.5. Solve for K, and that is by dividing both sides by 1.5, and the value of K equals 12. Write the variation function. Use 12 for K, so the equation becomes P equals 12S. So the equation of the variation is P equals 12S. Substitute 75 for P, 75 equals 12S. And then solve for S, and that is by dividing both sides by 12, and the value of S equals 6.25. So let us now proceed to method number 2. Use a proportion. Since K sub 1 equals K sub 2, so therefore, P sub 1 over S sub 1 equals P sub 2 over S sub 2. Replace the value so it becomes 18 over 1.5 equals 75 for the value of P sub 2 over S. Find the cross product. Then the equation becomes 18S equals 112.5. Solve for S by dividing both sides by 18 and the value of S equals 6.25.